All right, welcome to The Explainer. Today, we're diving into something that is, no joke, a revolutionary convergence. We're talking about what happens when you smash together the power of large language models, the AI that drives stuff like ChatGPT, with the very backbone of our digital lives, computer networking. I want you to just picture this for a second. What if, instead of typing out these long, cryptic lines of code, you could just talk to your network? You could just say, hey, prioritize all the video calls for the team in New York, or block any and all weird activity coming from this IP range. I know, it sounds like something straight out of a sci-fi movie, but it is way closer to reality than you might think.
But to really get why that idea is such a game changer, we have to look at the problem it's trying to solve. You see, for decades now, the way we manage networks hasn't just been complicated, it's been the main thing holding us back. It's a massive bottleneck.
And you can really see this problem when you look back at how we got here. Back in the 90s, everything was manual. Network admins were basically digital plumbers, using these command line interfaces to connect everything by hand. Super slow and super easy to make a mistake. Then the 2000s gave us some help with automation scripts, which was great for the repetitive stuff. Fast forward to the 2010s, and we get the first taste of AI with so-called autonomic networks, systems that could even self-heal a little. But, and this is the key, a human always had to be in the loop for the big, complex decisions, which of course brings us to right now and this quest for a truly autonomous future.
This is exactly why the old way of doing things is hitting a wall. I mean, think about it. A modern network is this crazy tangled web of routers, switches, and firewalls, often from a dozen different companies that don't use the same language. Setting it all up is slow, it costs a ton of money, and a single typo can literally take down an entire company's operations. This just doesn't work anymore. It can't scale for the kind of on-demand world we all live in.
And this is where it gets really interesting. This is where large language models, or LLMs, come into the story. The best way to think about them, they're like a universal translator, finally building a bridge between what we want to do and the complex language the machines actually understand.
So what is an LLM, really? Well, at its core, it's a very advanced AI, typically built on something called a transformer architecture. And it's been trained on, well, basically the internet, a staggering amount of text from books, articles, websites, you name it. And all that training lets it do more than just spot keywords. It can actually understand context, nuance, and the ridiculously complex patterns that make up human language. It can understand, it can generate, and it can reason about language with shocking accuracy. And believe me, this isn't just some fringe theory. Just look at how the academic interest in this has absolutely exploded. A recent survey checked out publications on this topic. In 2021, there was one paper, just one. In 2022, still just one. But then look at 2023, 22 papers. That's not a trend, that's a wildfire. It tells you the entire research community is racing to figure this out.
And this slide right here, this is the aha moment. This is why everyone's so excited. Look at the before. The human goal is so simple, so clear. Spread the traffic out evenly. Easy. But look at the after. The actual command you have to type is this string of indecipherable technobabble that only a certified expert would know. The promise of LLMs is to completely erase that gap, to translate our simple intent directly into that perfect complex command. Okay, so if LLMs are the bridge, how are people actually using this technology today? Because this has already leaped off the pages of research papers and into the real world in ways that affect the entire life cycle of a network. If you look at where the research is focused, it breaks down into 4 big areas. The biggest piece of the pie, at over 40%, is network automation. No surprise there, it's all about using LLMs to handle those tedious, mistake-prone configuration jobs. After that, you've got network security, where AIs can spot threats, and then network design and optimization, which are tied. And this research is leading to real tools you can point to. For automation, there's stuff like Switch, which literally translates plain English into the code for a network switch. For design, there's a copilot called GNet that can update network diagrams from text or even a picture you give it.
In optimization, a tool called LLM ABR is designing video streaming algorithms on its own to help kill that dreaded buffering wheel. And for security, you have things like Shield GPT that can predict and fight off denial of service attacks. And these tools are getting shockingly good. There's one model called Preconfig, and its whole job is to handle network configurations. Get this. It hit over 95% accuracy when analyzing existing network setups and was almost 90% accurate in translating configurations between different brands. So these aren't just toys. They are becoming highly specialized, very accurate tools. But of course, it's not a perfectly clear path forward. Let's pump the brakes for a second, because the road to a fully autonomous, self-driving network has some pretty massive potholes we need to deal with first.
And these challenges are serious. You have to ask the big questions. Can these models even run in real time without bogging down the whole network? How can you possibly use them without feeding them sensitive company data? A huge one is explainability. If an AI changes something, an engineer needs to know why. You can't have a black box running your network. It's just too dangerous. And maybe the scariest problem of all is what we call hallucinations. That's when an LLM just makes something up. It generates an answer that sounds totally right but is dead wrong. Answering a history question wrong is one thing. Giving a network a wrong command, that could be catastrophic. But even with all those hurdles, the vision for where this is all going is, well, it's incredibly powerful. We're talking about a brand new era of genuinely intelligent infrastructure. The end game, the ultimate goal here isn't just about automation. It's about autonomy. We're trying to build networks that can heal themselves before a human even knows something is broken. Networks that adapt to new traffic patterns in real time and, over time, actually evolve to become better. And for you and me, what does that mean? It means faster, way more reliable, and more secure services for everything we do online. So, in the end, this tech is forcing us to really think about the fundamental nature of control. As we start handing over more and more of these complex decisions to these incredibly intelligent systems, we're left with this one profound question. When the network can finally think for itself, who is really in control? That's the challenge and the huge opportunity we're facing. Thanks for watching.